In order to determine if the Tanuki practices daily torpor, like small mammals, or extended torpor, like the bear, troublesome Tanuki were live trapped from two local apple orchards. One orchard is adjacent to a Buddhist cemetery, and the other was in a more remote location. Because Tanuki are omnivores, they can be trapped with bait such as corn, grapes, apple, and also fish and meat. However, a largely vegetarian diet does not mean that the Tanuki is always sweet and gentle. They have two strategies for defense. The first is to be aggressive. The second strategy is to play dead when no avenue of escape is apparent. This Tanuki was caught by hand because she suddenly chose to become limp and immobile, relying on her camouflage for protection rather than running away. Many an inexperienced hunter has put down an apparently dead Tanuki, only to turn around and find that it has mysteriously disappeared, just as folk stories tell. Temperature can be very accurately recorded for many months using digital dataloggers. At the zoo hospital, a sterile temperature datalogger that recorded body temperature every 8 minutes for 5 months was attached to the inner wall of the intraperitoneal cavity of the Tanuki. Two weeks later, after the Tanuki had fully recovered from surgery, they were lightly sedated and fitted with radio collars. The next day, they were released where they were trapped and followed via a very tortuous path back to their dens. Finding their dens is not an easy process, because Tanukis rather sensibly appear to avoid their dens if they are being followed. Locating a Tanuki's den is difficult in autumn, since they rarely return to their dens because they are busy feeding night and day, endeavouring to accumulate as much fat as possible before snow covers the land. It is made doubly difficult because the snow bamboo groves in which Tanuki dens are often located is an interlacing network of tough stems that make passage difficult and quiet passage impossible. By the time the first snow has fallen, the Tanukis have doubled their summer body weight and retired to their dens. Once the snow has fallen, many rural roads become unpassable by vehicle. Locating the dens is easier now, but the effort required to travel overland is considerable, but balanced by the beauty of the surroundings. Regular checking upon the dens reveals that Tanuki spend 2 or 3 days at a time inside their den, but do on occasion venture outside. The den temperature is maintained at a comfortable 4 degrees C and insulates the Tanuki from outside temperatures of -20 or -30, typical of January. To our surprise, the Tanuki caught at the orchard is found to be living, along with at least 7 other Tanuki, in the water drains that run under the Buddhist cemetery. All things being considered, the cemetery is a prime location for the Tanuki. It is close to the orchard, so that apples and grapes are on the menu in summer. And on many occasions during the year, Japanese Buddhists place offerings of food and drink in front of the headstones for the spirits to consume. In the evenings, after all the humans have returned home, these become a smorgasbord of dining opportunity for the Tanuki, who make this cemetery their home. The water drains provide an extensive network of safe, artificial passageways with the convenience of multiple entrances and exits, and approximate the conditions of a super den with underground temperatures maintained between a cosy 2 and -2 degrees C. Our second big surprise was the discovery that the radio-collared young female and the dominant big male that lived in separate valleys during the summer became a cohabiting pair during the winter, who also shared their den with another younger male. In late winter, we positioned an infrared-activated flash camera outside their den and found that daytime visitors were mainly researchers and the occasional fox. Nighttime was more active. The Tanuki ventured forth to their doorstep to urinate and watch the world go by. Foxes and martens regularly visited the den, but didn't dare go inside. The Tanuki's survival over winter depends upon their ability to slowly metabolise the enormous amounts of body fat they accumulated over autumn. The physiological mechanisms by which hormones released from the Tanuki's body fat act to inhibit their hunger and motivation to search for food is still a mystery, but one that may prove insightful for the understanding of human obesity. These adaptations determine that during winter, competition for food between the Tanuki, the fox and the marten is minimal, since the Tanuki does not need to eat. The marten and the fox, on the other hand, are constantly on the hunt and can be regularly sighted during winter, provided you know where and when to look.
Spring comes slowly. The snow begins to melt and the creeks and rivers rise. The powdered snow that insulated animals living underground becomes heavy and wet. These new conditions are still far from ideal for the Tanuki, and for the most part they stay in or close to their dens. The first animal of spring is not the arrival or emergence of an exotic mammal, but dust that appears to jump. Closer examination reveals a spring specialist, the springtail. They flip about on the surface of the snow, waiting for their chance to mate, long before plants and animals are able to productively exploit this wet but still cold environment. Although springtails are indeed most visible in spring, they achieve propulsion with legs rather than a tail.
Melting snow reveals a countryside that resembles an elephant's sparsely haired back, which becomes noisy from the speed of human movements. In the town, we see a procession of color in the petals of crocuses, daffodils, tulips, irises, cherry blossoms, and tampoko.
Around the Tanuki's den, the predominantly brown landscape is first coloured by fly-pollinated plants, such as the thermogenic zazenso, a truly amazing plant, the spectacular mizubasho, and the mosaic yellow cabbage. The snow bamboo and forests are slower to respond to the warmth of the spring sun and will green up and add foliage in the following weeks. By early spring, it is clear that the dominant male has started to leave the den and doesn't always return each day. The pressure is really on to recatch our volunteer Tanuki before they leave their dens and start to forage widely. If we can't trap them soon, the transmitter batteries will lose power, and as cryptic as the Tanuki are, we will probably lose them forever. No Tanuki, no data. But they seem to remember being trapped last autumn and proved to be very evasive. We can spot them, but we just can't catch them. Using a new strategy, we build and then hide a tube trap inside the entrance of the den when the Tanuki are away foraging. In theory, the Tanuki will be trapped as they enter their den after returning home. This proves to be effective.
Yep, he's in there. We've got him.
But embarrassingly, we catch the old dominant male while he is visiting an attractive girl Tanuki at a distant den, thus putting paid to the rumours that Tanukis are always monogamous.
Oh, and the end result? We have our Tanuki in the bag, and let's just listen to make sure that it's him. This is our Tanuki with the radio transmitter. Beep, beep, beep. Good. Okay. Worry.
With the Tanuki literally safely in the bag, we take them to the zoo to remove the parasites they are playing host to. Shortly after, they will undergo surgery to remove their dataloggers.
That's the last surgery to retrieve the temperature data loggers that we
implanted into the Tanuki last autumn, 4 or 5 months ago. Surgery was uncomplicated and each animal is expected to make a complete recovery. In a week we'll remove the stitches and then a day or so later we'll take the animal to their den and we'll let them go.
Although it's really wonderful to see them go, it's also very sad. These Tanukis have been the focus of a lot of our efforts and thought over the last few months, and I'll miss them. This study has been hard work, but by forcing us to follow the Tanuki and spy upon their winter lives, it gave us an increasingly unchosen opportunity to see firsthand so many treasures and trials and deaths and births that occur in the total absence of the human eye, in a landscape that beguiles you with its quiet, clean, soft-edged beauty as it silently overpowers your body's thermogenic capacity and will kill you and all who are not perfectly prepared or adapted.
What did the Tanukis do in the winter time, sitting in their den? Did they hibernate or did they just sit there, slowly consuming their body fat, waiting for the arrival of spring? The answer to these questions is in here, in our temperature data loggers. So let's head on over to the laboratory, download the data and see what we see. Let's go.
Life in Hokkaido can be rich and rewarding. But unfortunately, science funding is not always based upon a meritocracy. This is very true if you are researching in Japan and are not Japanese. Before this research is completed, our neuroscientist finds himself without government or university support. These protective policies stifle many aspects of research in Japan, but determined that this story gets an unexpected additional international dimension because we'll finish our Tanuki story from Taiwan.
Please, come in. Take a seat. There's plenty to choose from. Imagine that you're at a university lecture. To our relief, the temperature data loggers worked perfectly. Physiologically, there appears to be no difference between the Tanukis that live far away in the mountains and those that live closer to humans around the cemetery. Surprisingly, the folk tales about the Tanuki appear to be predictive of his physiology, in that he is in fact just a pretender. He looks like one thing, but is actually something completely different. Now, let's have a look at the results in more detail.
First, we need an axis on which to display changes in temperature. On the x-axis, we want to display the changes in temperature over the months of late autumn, winter, and early spring. An additional y-axis on the right-hand side of the graph will enable us to display the depth of snow. This recording comes from the meteorological station at Asakawa Airport, and the snow depth is less than around the Tanuki's den, but it is a useful approximation. Average daily air temperature was continually below zero by late November. January was the coldest month, with a minimum temperature of -28 degrees C. By late March, average daily temperature had risen to above freezing. Inside the Tanuki's den, the temperature was buffered from the extremes of the air temperature and was stable between 2 and 4 degrees C, even on the coldest winter days. And now, for our scientific eureka moment, the body temperature of the Tanuki was maintained above 35 degrees C for the duration of the winter. They did not hibernate. A comparison of the winter body temperature of the Tanuki with the hypothermic profile of classical hibernators, or animals that utilise daily torpor when food is unavailable, or bears that utilise extended torpor, demonstrates clearly that the Tanuki doesn't use any of the recognised forms of hibernation during the long time they remain in their den. However, the Tanuki displays a temperature profile somewhat intermediary between animals that display forms of hibernation and animals like humans that maintain body temperature within narrow limits. The Tanuki's winter survival strategy is remarkably like humans in a similar environment. They stockpile food reserves, in their case they accumulate body fat reserves, and minimise energy consumption by drastically reducing energy expenditure. They have an extreme stay-at-home indoors strategy. They are the ultimate example of the winter couch potato,